All right, so I'm sorry, some technical issue was there, so due to that, the session has begun a little delayed. So, guys, very good afternoon to everyone, and welcome to the NEET Success Simplified channel. And I am your very own Dr. Umashankar, and I am here to discuss and continue with the vectors. Okay, so in the last session, guys, we have been talking about the vectors, and in this session, we are going to continue with the concept of the vectors. So the live students can tell me if you can see me and hear me properly. Yeah, can you guys see me and hear me properly? Very good afternoon to everyone. So yes, so guys, in the last session we have been speaking of the vectors. Okay, so guys, in the last session, what we have done? In the last session, what we have done? So in the last session, guys, we have been speaking of the vectors. Okay, we were talking in the vectors. Okay, we were talking in the vectors in the last session, and in the last session we have understood many concepts. So we have understood the basics of vector. How do we represent the vector? Okay, how do we represent the vector? We have learned. Okay, then we also have understood that how do we represent the vector? What is the angle between the vector? Okay, what is the angle between the vector, right? Okay, we have understood the graphical method of vector addition, graphical methods of vector addition. Okay, so if you guys haven't watched the last session before this session, you need to watch the last session because this is going to be carry forward. It is going to be carry forward from that session only. So basically, in this session, we are going to see much more concepts of the vectors. Okay, but before that, You need to go to watch the last session if you haven't already. So again, I welcome all the live students here. Okay, I welcome all the live students here, and I welcome you all in this session. So I'm waiting for the live students to join the session, and afterwards we will continue. We can continue with the session. Okay. So the live students. Sorry, today's session started a bit late due to some technical difficulties, and so hopefully that we can continue from. Hello, Shrisai. I was waiting for you actually. So because of some technical issue, the session has started 2 3 5 minutes late. Okay. Okay, I'm very sorry for that. Okay. So let's start with the session. Okay. So in the last session, guys, we have spoken about the basics of vector. We have seen that what is how we approach graphically, how we can approach graphically in any vector. Okay, how we approach graphically in any vector. Now we will be continuing the concept through the analytical means. Okay. So in the last session, basically, if briefly I give you a review. So when we add two vectors, okay, we get some resultant, and we can have it added by the help of what? So normally we apply the law of triangle of vectors, or we apply the law of parallelogram of vectors. Okay, so just giving you a review. So let's suppose two vectors are there. One is vector A, one is vector B somewhere, or like the last session, there is some vector B and there is some vector A. And now we need to add these vectors. So what could we do, sir? So we can do like this. So A vector. So if we apply the law of triangle of vectors, so from the end of one vector, another vector you can start. So this is going to be your B vector. Okay. Okay. And the resultant of A and B would be given by the third side of this triangle. Okay, taken in the opposite order. So this is going to be the resultant of it. This was the resultant to it, right? We remember that. So this is the triangle law. Okay, so see, we have to use these laws very extensively. So, graphical understanding is also very, very important. This is of utmost important. Now, please understand this. Now, these two vectors, we can use the parallelogram law as well. Okay, we can use the parallelogram law as well to find the resultant. So in this section, basically, when we talk about the analytical way, so see, we will be deriving some sort of equation, some formula in the what in the from the parallelogram law, and then we will be seeing how to use those formulas in addition and subtraction. As I keep saying, there is nothing like subtraction of vectors. Vectors are always added, so you are going to get the concept of that also in this section. Okay. Now talking about the parallelogram law, if I want to find the resultant of these two vectors through parallelogram, so what I needed to do? Sir, you need to join them tail to tail. This is what we have learned in the last section. And when you join them tail to tail, their resultant, and you complete the uh, parallelogram like this. Okay. Okay, the resultant of these would be given by the diagonal of this parallelogram, and that diagonal must come out from the same intersection point. Okay, okay, are you getting my point? Yeah. So this much we have seen in the last section, and I'm hoping that there is no confusion in the last section till this point. Yeah, live students can tell me if we have any confusion till this point. This much is okay, right? Wonderful. This much is okay to you. Now let's move forward with the analytical way. Now please understand this. So in analytical way, basically what I'm trying to do here, I'm trying to give you a beautiful formula. Okay, we are trying to develop a beautiful formula, okay, using which we can find the resultant, the direction. So we used to find the resultant and direction. We used to find the resultant and direction using this graphical way also. Now the same thing we have to do through a analytical approach. The same thing we need to do through a analytical approach. Okay, so what approach are we going to put in? Now please understand this. So we are having two vectors. Let's suppose this is vector A and this is vector B, and we are joining them tail to tail. Okay, we are joining them tail to tail. Okay, vector A and vector B. Now you know already so that the resultant of this two vectors will be given by the diagonal. The resultant of these two vectors are going to be given by the diagonal of this parallelogram where the resultant is coming from, the common intersection of these two vectors, that is from the common tail or wherever the tail is meeting here, right? Are you getting my point? Okay, okay, wonderful, wonderful. Now please understand this. So we have this parallelogram law of vectors. Now let's suppose that the angle between this A and B is theta. Okay, very well, sir. Very well. And now we know that the sides. Hello, Bima. How are you doing, Bida? How are you doing? I'm hoping you are doing well. Okay, so I hope you have watched the last session too. Now, in this case, what is going to happen? So we are having this A, we are having this B, and this is going to be the resultant R. And now let's try to derive this R. Let's try to make a formula of this R. So see how we can do it. Now let's understand this. Now, if I make a perpendicular line here, and if I extend this line, so let's name them O. You can name them anything. Let's say M and P. Okay. Now this OM we have extended to P, and this is obviously 90 degree. So this angle is theta. This angle is theta. So this is angle is also theta. How come, sir, it is theta? Because see, it is the parallelogram. So if this is B, this has to be B. And remember, this A, B are the lengths of this vector. So they are referring to the magnitude. This is also very important. Okay. Please try to understand this. So this is referring to the magnitude. Okay. Okay. Now please observe. Now please observe. So we have made this one more triangle, and if we look at this triangle M and P. So sir, we want to find this R. Now can you observe in triangle ONP? We can easily apply the law Pythagoras theorem. So can we write RM square is equal to OP square plus PN square? Can we or can't we? Definitely, sir, we can do that. Definitely, sir, we can do that. Okay. R square is equal to OP square plus PN square. So why we are doing so? Because ultimately we want to find this R. So I can see this R in a right angle triangle. And as soon as I see a right angle triangle, I always do this thing. I always do this thing. I hope it is fine to everyone. So R square is equal to OP square plus PN square. Wonderful, sir. Now, in order to find R, I need the values of this OP and PN. I hope you understand that. Now, if I see in triangle MNP, I have one more triangle here, that is MNP. So, in this triangle MNP, we understand that the sine theta is equal to Pn upon Mn, isn't it? Okay. Now, can I write this Pn? So, Mn is equal to B. Okay, because this refers to the length, right? So, Mn refers to this B, and this is sine theta. So, can we write Pn is equal to B sine theta? Definitely, sir, definitely. And we can also observe that so this OP is made up of this OM and MP. OM is already A. Now, if I write MP, can we say that cos theta is equal to base upon hypotenuse? So, I'm seeing in the triangle MNP. So, can we write it as MP upon MN? Okay. Now, from here, so why you are deriving it? See, its derivation is very, very important. When you are going to see, as I say always, that in physics you must hold your concepts. Okay. No worries, Viva. Okay, you may watch the recording later. Okay, okay, because this section is very, very important. Okay, because see, vectors are in use to many chapters further. Na? So we'll be dealing with the forces. This concept will be working there also. Velocity, change in acceleration. So for all that, this is a very basic. So you have to you have to see this later. Okay. Okay, no worries, beta. So now cos theta is equal to MP upon Mn. So Mn is B. So MP is B cos theta. And remember again I am saying that here BA refers to the magnitude of the vector A and B. They are the magnitude of these vectors. Okay. Now from here can we write R square is equal to, so this is OP square. So OP is A plus, OP is A plus MP is B cos theta. So it is going to be A plus B cos theta. A plus B cos theta whole of a square plus, okay, plus Pn. So Pn is B sine theta whole of a square. B sine theta whole of a square, right? Now from here can we write R square is equal to, so if we open up the bracket, it will become A square plus B square cos square theta, okay, plus 2AB cos theta, 2AB cos theta plus B square sin square theta, isn't it? Now from here, can we write? Now here, can we write? Now see, A square, now B square cos square theta plus B square sin square theta, it is going to become B square. So it will become A square plus B square plus 2AB cos theta plus 2AB cos theta, and this is going to be equal to R square. This is going to be equal to R square. So R square will be becoming A square plus B square plus 2AB cos theta, and from here we can write R is equal to A square plus B square plus 2AB cos theta, and here comes the very famous formula from the law of parallelogram of vectors. Now please tell me if it is clear up to this point or not. Yes or no? Is it clear up to this point or not? Please answer me. Yeah? What do you think? Is it clear up to this point or not? What do you think? Yeah? Can we say it is clear up to this point? Right? Now, wherever you are using this formula, please do remember that A and B refers to the magnitude of those vectors. From here, R is also the magnitude of that vector, and cos theta. So the theta is the angle between these two vectors. Angle between these two vectors. So we have to be careful with that. So does it have any significance? Yes, it certainly have a lot and lot of significance. Trust me on that. Okay. So we are having this. Okay, sir. Wonderful. Now, sir, we also have understood that whenever two vectors are added, their result is also a vector. So, sir, we want to have the direction of R also. See, in the graphical method, we can clearly have the direction. Okay. In the graphical method also, we can clearly have the direction. Now, same way in the analytical method also, we need the direction. In the analytical method also, we need the directions. Okay, so from where I can get the direction? Now, please understand this. So, this is R, A, B. Now, if I say this angle is alpha, now again you see in triangle, in triangle O and P, in triangle O and P. Now, in this triangle O and P, can we say that tan alpha is equal to Pn? Now, please observe, tan alpha is equal to Pn upon OP. Now, from here we can say that tan alpha is equal to Pn. So, Pn is B sine theta. Pn is B sine theta, and OP is OM, that is A plus PM. PM is B cos theta. Okay. Okay. So from here, can we get, if we solve this equation, we obviously are going to get the alpha from here. And now when we are getting alpha from here, this angle will give you the direction of this resultant vector. Do you agree to it or not? And here the alpha is taken from A. Okay. So when you are giving this angle, you also must tell that from where, which vector, from which reference this angle is taken. Okay. So alpha is taken from the what? From A. So when we are writing it from A, understood, Vida? Understood. Now you can see the pattern also. So if I say when two vectors are added, A plus B, okay. So if we generalize this concept, so if two vectors are added, A plus B, so their resultant is also a vector. This much we know. And this resultant, if you want to find, so see, any vector is having two things. One is its magnitude, and one is the uh, direction. So a square plus b square plus 2ab cos theta, right? Okay, a square plus b square plus 2ab cos of theta, right? This is going to be the resultant magnitude. And what is going to be the direction, sir? So for direction we can do tan alpha is equal to, now please observe, so if you are trying to get the angle, so this is A, this is B, and if you want to see the angle of this resultant from A, now see, it is very easy to memorize also, although you must know that from where it came from. So tan alpha is going to become, so see, it is this alpha you have taken from A, so keeping A alone in the denominator, the remaining B sin theta plus B cos theta. Sir, how come, sir? So see, when we are writing tan theta, so sin theta must be in the numerator, cos theta must be in the denominator. This is the general understanding. Okay. Now same way we did some improvisation and we have written like this. Okay. Okay, now for example, if we want to have this angle beta, not it is always necessary, na? That's where we get the angle from A. Now, if we want the angle of this from beta, and theta is the angle between these two vectors, right? That is already known to us. Theta is the angle between these two vectors. Now, if we want beta, so either we can do this, or if we have the alpha, so obviously beta is going to be theta is equal to theta minus alpha. Understood, beta? Understood? Okay. Okay, and this tan beta. So if we want to write this tan beta, so beta angle is taken from B. So you are keeping B alone in the denominator. The remaining vector magnitude you can use like this. Okay. Okay. Now please tell me if it is clear or not. Please answer me. Yes or no? We have got the magnitude as well. We have got the direction as well. So for our vector, these two things are important only. Yes or no? Please answer me. Wonderful. Now let's solve a few questions to have a better understanding of it. And now the students, please try to know one more thing here. Please try to understand one more thing here. See what is happening. See what happened. Sometimes in the question, it is easy to go with the analytical method. And sometimes in the question, it is easy when you go with the graphical method. Now, in the question, you have to judge, you have to think that from where I shall start the approach of the question. Are you getting my point? Like for example, see, but this is going to be, see, you now come to know both methods, graphical and analytical. Now, with questions will evolve. Okay, with question will evolve this understanding that how we can use all these concepts, how we can apply all these concepts for understanding of the vectors. Understood? Okay, so how we are going to do that? Now, please understand. Now, please understand this. So let's see a question. So let's say we have two forces. We have two forces, each of magnitude, each of magnitude 10 Newton. We have two forces, and the magnitude of each of it is 10 Newton, acting at a point, acting at a point. Okay, so we have two forces of 10 Newton and they are acting at a point. So you need to find the resultant. You need to find the resultant. Okay, you need to find the resultant, and they are acting somewhat like this. Okay, this is also, let me give you. So this is 10 Newton, this is 10 Newton. Okay, so what is going to be the resultant of it? So I'll just give you some options. So it is 10 root 3, 30 degree from horizontal, from horizontal. Okay, it may be 10 root 3, 10 root 3. Okay, 60 degree, let's say 60 degree from horizontal, 60 degree from horizontal, or it is 10 root 2. Okay, and this is 30 degree from horizontal, 30 degree from horizontal, or it may be 10 root 2. Okay, and this is 60 degree from horizontal, 60 degree from horizontal, and the angle between two vectors is 60 degree. Now you can try this question. Please go for it. I'm very sure we can do. I'm very sure we can do. Now how it is A and B both? No, it is A only. Okay, now let's try to do this question. Okay, now in this question, guys, now in this question, please try to understand this. In this question, what happens? So first of all, there are two vectors. Now see, we can go by the formula also. See, in the examination, if we can save some 30-40 seconds in a question, that is a big thing. Now please understand this, how we must do in the examination in the exam hall. So two forces each of magnitude 10 Newton acting at a point, and we need to find the resultant of it. So first of all, whenever two forces are equal, whenever two vectors, forces is the vector, so we know that whenever two vectors are of equal magnitude and they are at some angle between them, there is some angle between them, their resultant is exactly in between these two vectors. This is something we grabbed in the last session. Did we or didn't we? So now the first thing is very clear that the angle between these two vectors is going to be 30 degree. The angle between the resultant is going to be 30 degree. Is it fine? From there. So see, one way one you can do, you can apply this formula, you can make the calculation. Okay, but this is a better way now. This is a better way. You can go by the formula also. So we can use the formula for that also now. Tan alpha is equal to, so we wanted it from the horizontal. So 10 sine 60 plus 10 cos 60. Okay, so I'm very sure when you solve this, you are going to get alpha is equal to 30 degree. Okay, because see, clearly from the understanding we had in the graphical method, we came to know that whenever two vectors are equal in magnitude, ha, acha, no problem, she said, no problem. Okay, no problem. So the alpha is going to be 30 degree then, right? Okay, alpha is going to be 30 degree from here also. But do we need to do this calculation? Do we need to waste our time here? No, sir, because we have understood when two vectors, again I'm saying, when two vectors, they are equal and there is some angle between them, their resultant is going to be exactly in the middle of it. Okay, so no need, it is going to be 30 degree. Now secondly, so we want to find the magnitude. Now see, 10 root 2, it can't be 10 root 2. Why it can't be 10 root 2? Because we have seen that this thing will only happen when both are in 90 degree. Graphically, we did it now. Okay, but still, if we want to calculate, if we want to calculate, so we can go by finding the resultant. So what is the resultant in magnitude? So it is a square plus b square plus 2ab cos of theta. So from here we can write r is equal to a square, that is 10 square plus 10 square plus 2 into 10 into 10, and theta is 60. So from here we are getting 10 root 3. Okay. By 2 cos 60 is going to be equal to 1 only, because cos 60 is 1 by 2. So 2 by 2, that is 1. So it is going to be 10 root 3. So resultant is going to be 10 root 3 Newton. Okay. Do you agree? Yes or no? Please answer me, my dear. Yeah. Very, very simple, no? Very, very simple. Okay. Now let us solve one more question. So let us suppose there are two forces. Okay. Let us suppose there are two forces whose magnitude, there are two forces whose magnitude are in the ratio, whose magnitude are in the ratio of, whose magnitude are in the ratio of 3 is to 5. Magnitude are in the ratio of 3 is to 5, and their resultant and resultant is their resultant is 28 Newton. Their resultant is 28 Newton. So if the angle if the angle between their, or angle between them is 60 degree. If the angle between them is 60 degree, find the magnitude of find the magnitude of each of these forces. आपको क्या करना है? You need to find the magnitude of each of these forces. Okay. Okay. So I'll give you some you know, options here. So we have 16 Newton, 24 Newton. We have 12 Newton, 16 Newton. Okay, we have 12 Newton, 20 Newton. We have 16 Newton and 20 Newton. Can you please try this question? I'm very sure we can do it. Please go for it. Please go for it. Please go for it. I'm very sure we can do. So here two forces whose magnitude is given are in the ratio of this and this. So you can go for it. Please go for it. Ah, okay, wonderful. I'm waiting for you to do. 4. 4 is not in the option even. 4 is not in the option even. Anything else? Okay, so you are given the answer is okay. Seems correct. Seems to be correct. Okay, let's see. Let's check. Let's check. So now two forces whose magnitude are in the ratio of 3:5 and their resultant is 28 Newton. So you can pick up two forces as 3x and 5x, or you can simply two forces are there, let's say A and B. So they are in the ratio of 3:5. Okay. Okay. So if one force is A, the other force is, or I can say simply, if one force is A, other is 3 by 5 of A, right? Okay, so one way you can do like this also, or another way, yeah, another way could be, I think, as you have done. So you may have taken, sir, one is 3x or 3a, another is 5a. Both are the same thing. Okay, we will get both the answers. So I think you have done from this. So I'll do from this. Okay, so that you get the both the ways. Okay, so here so shall we go with the graphical approach or the analytical approach? So here approach will be better because you are don't having the values here. So you need to find the value. So we'll go by the analytical approach. So see how we are going to do that. So resultant, sir, we know it is equal to r square is equal to a square plus b square plus 2ab cos theta. So now what we can do, sir? So r square is given as 28. So we can write 28 square is equal to, let's suppose this is a square. The other is, yeah, other is 3 by 5 of a square. Then we have 2 into a into 3 by 5 of a, and this cos theta that is given as cos 60. Okay, cos 60. So it is going to become 28 square is equal to, so we can take the LCM. So we can write 25 of a square plus 9 of a square plus, this is going to be 5 into how much? 5 into 6, that is 30, isn't it? Okay. Okay. So this is going to be, okay, 5 into 6, that is 30, and this is cos 60. So cos 60 is 1 by 2. So can I write it 15 directly? Yes, sir, you can. Okay. How come, sir? So see, cos 60 and 2. So 2 and 1 by 2, they will become 1. So I have just taken the LCM. So from here, can we write? So 25 plus 9, that is 34. 34 plus 15, that is 49. Can you see me? Seems to have some technical issue. Sign. Can you see me? So you are saying, sir, I got 15 there. Check again. Okay, okay. So we have also got 15 there, na? 30 cos 60 I was writing, na? So 30 cos 60 is what? 30 cos 60 is 15 only, na? Yeah. Yeah. Yes, I'll catch up with the chat, na? Because just a moment, because I see your chat in the mobile. Just something. So it lagged. Yeah, some technical issue happened. I don't know what technical issue happened. Can you give me a moment? Yeah, let me see to it. Okay, okay. No worries. Your answer is correct only. It was 30 cos 60, right? It was 30 cos 60. Okay, I think it is working now. Yeah, sure. Good to go. Good to go. Yeah. Okay, let's continue. Let's continue. Now please understand this. So from here can we write A is equal to 20 Newton. Now when A is equal to 20 Newton, the other vector is 3 by 5 of 20. The other force is 3 by 5 of 20. So it is going to be 12 Newton. So which option is matching here? So C option is matching. Is that clear? Is that clear, my dear? Yes, sir. It is clear to you. Okay. Okay. So now these basic kind of questions, I hope you will be able to do. Now let's move a little further with some more understanding. Now if I say, please understand this, if I say that the angle between two vectors is exactly 180 degree. The angle between two vectors is because see we already know this now. We already know this thing. So what do we know? So, sir, we already know this thing. So, we already know this thing that the angle between two vectors is always between 0 and 180. So, in the last session also we have been talking about it. Now, if I take this up as a case, so if I say case one, now let's take theta is equal to 0 degree. Now if in this case I take theta is equal to 0 degree and I use the formula, so r square is equal to a square plus b square plus 2ab cos 0, right? Now cos 0 becomes 1. So can I write it that a plus b whole of a square and r square. So in this case, r is equal to a plus b. So this thing I shown you lastly also na graphically that when the angle between two vectors is 0, that means they are in the same direction. Now when they are in the same direction, their magnitude is going to get added. Okay, and remember in this equation when you are writing r square is equal to a square plus b square plus 2ab cos theta, so here R, A, B, all are the magnitudes of the vector. Okay, okay, okay. So I hope this is clear. Now similarly, if I say case two, so in this case two, can we say theta is equal to 180 degree? Now when theta is equal to 180 degree, if you put it in the formula, so we have R square is equal to A square plus B square plus 2AB cos 180 degrees. So now in this case, what is going to happen, sir? Now in this case, R is going to be A square plus B square minus 2AB. Yes, 0 and 180. Yeah, yeah. Graphically, it was more easy, but I'm just trying to, rephrase this thing. So A minus B whole of a square. Okay. Okay, so R is equal to A minus B. So 180 degree means two vectors. They are opposite directions. So obviously they are going to get subtracted. Okay, so what you are trying to establish, sir? So when two vectors are added, this is something I told you in the last session also. So when two vectors are added, the magnitude of their resultant always lies between their difference of the magnitude of these vectors, and it is less than equal to A plus B. Yeah, okay, okay. And I must write it like this basically, A minus B. So we know this is the magnitude, A plus B. Okay, so this is something we learned in the last session too. Yes or no? Right? Yes or no, my dear? Please answer me. Yeah, yeah, wonderful. Now, please understand one more thing. So, when I say A minus B, I doesn't mean so. My video is somewhat. It is going fine now. Yeah, 2 plus 2 cannot be 5. Okay. Now, please understand this also. So, A minus B when I write, basically I mean A difference B. Are you getting my point? A difference B, because B can be more than A also. Na? B can be more than A also. Are you getting my point? B can be more than A also. Okay. Okay. So when we write it, this is the difference. So basically, we can write like this. We can write this as in mod. Are you getting my point? So basically, we are interested in the magnitude of this difference. It is, don't think that it is going to be into negative. Vector never have negative magnitude. So they do. They don't. Okay. Because see, minus sign in a vector refers to some direction. Are you getting my point? Okay. So basically, when I am writing the resultant, I mean the difference of when we use subtraction sign, we basically means the magnitude of that. Understood, my dear? Okay. Okay. So ultimately, we have come to understand this concept. Okay. And see, lot of questions are getting asked from this concept. Okay. Like this one. So this is a question of NEET only. So the resultant, the resultant of, the resultant of vector A, the resultant of, let's say, vector A, the resultant of vector A and vector B, the resultant of, no, no, see what happens. I'll explain this when we do the subtraction. So if vector is written like this, v2 minus v1. Okay, so let's suppose it is written like 10 meter per second. So if you put 10 meter per second minus, so let's suppose this is in east, so you will write like this, that 10 meter east. Okay, and what is this? Minus v1. So minus v1 means that it is, let's suppose, 10 meter west. Are you getting my point? So this minus sign refers to the direction basically. Okay, are you getting my point? Right. Okay. So don't take it like this, like sir, we can't write like this. 10, so literally you will see 10I, this is written 5J Cartesian. Okay, now this minus 5. So don't think that this is minus 5, that is the magnitude is in negative. Basically, it refers to be like this vector is somewhere here in J. Okay, in J, in minus coordinate. Are you getting my point? So here, this refers to the directions only. Okay, so plus minus in vectors are the referring to some direction of the vector. Okay, like for example, if I ask you one simple thing, there is a body. Okay, on this body there is one force, 20 Newton in this direction and 10 Newton in this direction. Are you getting my point? Okay, so 10 Newton in this direction. So what is the resultant force on this? So now if somebody is not knowing the vector at all, he will say that the net force on this is 10 Newton in this direction, 10 Newton in this direction. Are you getting my point? Yes or no? Now, what you have done, basically you subtracted these vectors. Why you have subtracted these vectors? because they were in the opposite direction. Are you getting my point? Okay. Okay. Yes or no? Right. So this direction you have taken as negative, and the length of this line, this vector gives you the magnitude. So there is no minus. So length cannot be in minus, right? Okay. I hope you got my point. Now, it says the resultant of A and B if oh, no worries. So the resultant of vector A and B cannot be the resultant of vector A and B cannot be इसके मैं आपको ऑप्शन दे देता हूँ 2 units, okay, 3 units, 4 units, or you know 8 units. Okay, and vector A is 3 and vector B is 4 units. Okay, this is given. Now, what is going to be the right answer? What is going to be the right answer? Can you answer me? Very, very simple. Can you please answer me this? So, sir, you would say, sir, obvious answer is D. Okay, why? Because when two vectors are 3 and 4, so that means the resultant will be, now you have to take the difference of it. So don't do A minus B, because if you do A minus B, you will write minus 1. It has no meaning. This is 1, 4 minus 3, and it has to be less than 7. So resultant has to be 1 to 7. Yes, very easy, no? And this kind of questions are asked in abundance if you see. Okay. So you know the resultant has to be somewhere between 1 and 7. So 8. 8 is outside this. Huh? So when 8 is outside this, 8 is outside this, so it cannot be 8 ever. It cannot be 8 ever. Right? Okay. I hope this is fine to you. Okay. Okay. Now let's move further. So lastly also we have seen one question. I just want to give you something more here. So last session we have seen this question. Okay. Now in the last session I asked you what is the angle if this is the condition. If this is the condition, the angle between A and B. So I'll just tell you something before that. We have seen this now in the last session. I'll just give you something before this. Now let me make one more case which is very frequently used. So that is case 3. Yeah, we cannot say from minus 7 to 7. Please have it in your mind. We can never say it is between minus 1 and 2 7. Right? Because this way it can be 0 also, na? Right? So there is no, see, you tell me one thing. So from the first day when we started, she said, just try to think in this way. Just give a moment of thought on this. So we understood that the vector, the magnitude of vector is given by the length of this head and tail thing. Okay, of this arrow, right? This arrow length gives the magnitude. Let's suppose this is 10, and let's suppose this is 10. Now, if I ask you, now if I ask, let's suppose it is 20. Okay, let's suppose it is 20. Now, if I ask you, Shitai, that what is the magnitude of this vector and what is the magnitude of this vector? What would you say? What would you say? What would you say? So you would say that the magnitude is 10 and you would say the magnitude is 20. Now, are you going to say minus 10 or minus 20? Just tell me that. Are you going to say minus 10 or minus 20? You are never going to tell me that. Are you getting my point? Are you getting my point? Now, if we find the resultant of it, what is going to be the resultant of it? The resultant is obviously going to be 10 Newton in this direction, 10 Newton in this direction. So, is there any scope of writing minus there in the resultant? Hmm? Not minus 20 and 10, or not minus 10 and 20. Are you getting my point? See, this is the play of direction. So, but later we subtract the forces. That is because their direction is different. Are you getting my point? Okay. Now their resultant will be 10 Newton in this direction. This 10 cannot be negative. Okay. But sir, later on, see, when we use some sign convention, what we say, we use the sign convention. That is the basic of this confusion. Because lately you are going to see if force is acting in this direction, it is tensile, it is pulling something, we consider it positive. You consider it positive. That means you have given sign to some direction. It doesn't mean that physical quantity become positive or negative. Just for the sake of calculations, you have given something a sign. Are you getting my point? Yeah, don't forget that. Okay, I think this point is clear. Now let's move to the case 3. Now, if the angle between two vectors is 90 degrees, so we have seen this graphically also. So if two vectors having their angles 90 degree between them, sir, we know the resultant is root over, or r square is, or resultant, I'll write root over a square plus b square, right? So we did it graphically also. Now, if you want to do it through this method of, analytical way, because see, analytical graphical method are going to give you the same result na, in any given case, right? Okay, so now if you write a square plus b square plus 2ab cos 90 becomes 0. So you are going to get this only na. R is equal to root over a square plus b square. Yeah, from Pythagoras also, from this formula also, whichever way you may want to go, right? Okay, whichever way you may want to go. Understood, beta? Understood? Please answer me. Okay, okay, wonderful, wonderful. Now please understand this also. Okay, so in the last session I also spoke about it, but I want you to give you one more view of it. So if two vectors a plus b, and this is written like this, so just tell me what is the angle between a and b? If this condition is there, what is the angle between a and b? And if this condition is there, if a plus b vector is added, and this becomes magnitude of a minus magnitude of b, okay? Okay, now in both the cases, what is going to be the angle? Can you tell me that? In the first case, in the second case? Please think before you say anything. Na? Think before you say anything, my dear. You can see it any way you want. Wrong answer, my dear. And lastly, also we spoke about it. Na? Theta is 0 and here theta is 180. Isn't it? Do you remember that or not? Huh? Yeah, 0 and 180. Now, how it come out to be 0? Because see, a plus b. Okay, now please understand. See how we get confused. Now, first tell me, let's focus on the first case. Is this thing, what thing? So, if this thing and this thing are the same thing or are different things? Are they mean the same or they meant differently? Are they same or are they different? Can you give me something on that? Are they same or are they different? They are different. Wonderful. Now please understand this. Now sometimes what happens now when when we read some more chapters, students forget this thing, forget the basic concept, and they get trapped in all these things. So A plus B, vector A plus B would be having some resultant. So when I write A plus B mod, that means we are talking about the magnitude of that resultant. Okay, magnitude of that resultant. And when the magnitude of that resultant is equal to the magnitude of those vector individually, it only happens when theta is equal to 0. We have did it in the case of what? In the case of that also, graphically also we have did this. Yes or no? Have we done it or not? Yeah, we did have done this, na? Okay, and if you want to see it with the formula also, now see in this formula, now r will become, let's do this. So A plus B is r now. So this means what? That the resultant of A and B becomes r is equal to A plus B. R is equal to A plus B. So this can only possible when theta is equal to 0. See, case, see here you have seen na, case 1, theta is equal to 0 degree, r is equal to A plus B. Now similarly, r is equal to A minus B, r is equal to A minus B, r is equal to A minus B. It is going to be, it is only happening when the angle between these two vectors are 180 degree. Yes or no? Yes or no? Okay, okay, please answer me. Right? Okay. Okay. So remember this thing. This is very, very important. Now let's move to some more questions. Okay. So see, now this concept, this very concept, you will see questions with the change languages. Okay. So in physics, they play with the English language a lot. Okay. Lately, also you are going to see, okay, some man is pulling a stone. He's pushing the stone. He's carrying the stone on his head. On both his, he's having something weight like this, right? Don't get trapped. Stick to your basic concept. The physics is extremely easy subject. Okay. Only the thing is that how far you go with your concept. Okay. Now please understand this. So see how they can change the language. So they can frame the similar concept question like this. So which pair of forces, which pair of forces can never give resultant, which pair of forces can never give resultant of 2 Newton. Okay, which forces can never give the resultant of two forces? So let us have some options. So 2 Newton and 2 Newton. Then we have uh, 1 Newton and 1 Newton. Then we have 1 Newton and 3 Newton. And we have 1 Newton and 4 Newton. So now, which pair of force can never give resultant of 2 Newton? Can you please tell me that? Can you please tell me that? Please go for it. Please try to answer it. Can you please answer it? Please try to do that. I'm very, very sure we can do it. Very easy, no? Very, very easy, no? Very easy, sir. Very, very easy. Now, please observe which pair of forces can never give resultant of 2 Newton. So, which pair of forces can never give resultant of 2 Newton? Sir, it is obviously D option. Okay, because see the difference, so if you see what could be the resultant. So this resultant can vary from 0 to 4. Or is the resultant, the magnitude of vector can be 0? Is it possible? What is your take on it? The magnitude of the resultant can be 0. Is it possible or is it not possible? So definitely, sir, it is possible. So we have seen the 0 vector, right? Okay. And this is going to be 3 and 5, right? Okay. Okay. So this is not possible because the resultant will be in the range of this 3 and 5. Resultant will be in the range of this 3 and 5. I hope this is fine to you. Okay. Okay. Now let's move a bit further with this. So these kind of a question you will be able to do, right? So let us do some more calculative kinds. Okay. So let's suppose we have the maximum and minimum, and minimum, the maximum and minimum magnitude. Let me write the question of resultant, the maximum and minimum magnitude of the resultant of two given vectors vectors two given vectors are 17 units and 7 units. 17 units and 7 units. Okay, 17 units and 7 units respectively. respectively. Okay. Now if these two vectors, if these two vectors are at right angles to each other, at right angles to each other, right angles to each other, the magnitude of their resultant is, the magnitude of their resultant is. Okay, so this is your question, and let's have solving it. A 14, B 16, very simple question. C 18 and D is 30. Yeah, wonderful. So you have given the answer very quickly. Okay. So the maximum and minimum magnitude of the resultant of two given vectors are 17 and 7. So some very simple question it is here. There is nothing in this question. So resultant, maximum resultant is A plus B. Let's suppose two vectors are A and B. So their resultant, the maximum magnitude of the resultant is 17. And we know the maximum magnitude cannot be more than A plus B. Now the minimum magnitude is 7. So minimum magnitude cannot be less than A minus B, right? Okay. So from here, what we can do? So from here, these two equations are there. So from these two equations, I can solve them. So when I solve them, I'll have to add these two equations. So 2A will become 24. A is going to become 12. Now A becomes 12. So B becomes how much? B becomes 5. Okay, A becomes 12, B becomes 5. Now two forces. Now see how quickly we can do it. Now two forces, that is 12 and 5, they are perpendicular to each other. So we know. So that is why we have seen this as a standard case. So this is 12 square plus 5 square. So 144 plus 25. A7 and B12. How? A7 and B12. That is, I didn't get that what you were trying to ask me. Sir, but A7 and B is 12. How come? How come? I didn't get what you are trying to tell me or ask me. Can you just explain that what you are trying to say? See, we are asked about can it be? Can it be what? 7 and 12 you have written. 7 and 12. So 7 and 12, the difference is 5, not 7. You have written 7 and 12, if I can see it. So when you are writing, my dear, 7 and 12, how the difference could be 7? Minimum magnitude. The minimum magnitude cannot be less than 7. Minimum magnitude is 7. It is given. So when minimum magnitude is 7, so minimum magnitude comes when the two vectors are subtracted. Out of 12 and 5, we calculated 12 and 5 only. Na? This is what we have calculated. So you are saying it could be 5 and 12. That is also fine. What is the problem? 5 and 12. The difference will be minus 7. No, the difference will be again 7 only. Because you always take the difference, the value. You never say minus. We just have understood this thing, didn't we? Yeah, I hope this is clear now. Yeah. So now when we are writing r is equal to 12 square plus 5 square, so it is 144 plus 25. So obviously it is 169. So root over 169 is 13. So can we say the option is D? Yeah. Please answer me. Simple question. Simple question, right? Simple question. Is it or isn't it? Please tell me, Vida. Is it or isn't it? Simple question. Yeah. Now can we move further? Okay. Now let's try one more question. Let's try one more question. You want to try one more question, right? Hmm? Yeah, yeah, too easy. So let's try one more question. Okay, let's see how you are going to do it. Very simple again, है ना? Not very difficult. Okay, the sum of the, but from this question I'll tell you many things. Okay, so the sum of the magnitude of two forces, two forces acting at a point, acting at a point. Okay, acting at a point is 18, is 18. Okay, and the magnitude of the resultant is 12. The magnitude of the resultant is 12. Okay, so if the resultant is, so if the resultant is 90 degree, if the resultant is 90 degree with the force, if the resultant is 90 degree with the force of a smaller magnitude, with the force of a smaller magnitude, with the force of a smaller magnitude, okay, the magnitude of the forces, the magnitude of the forces, the magnitude of the forces will be, okay, the magnitude of the forces will be option A, let's say 12, 6, option B, Danish, I'll just come back to that. 15, 3, C, 13, 5, okay, and D is 10 8. Okay, now let's try this question. Now I have a question. So meanwhile, she say, sometime I definitely give you some time. Okay, so Danish. Sir, you are asking, my dear, sir, can I crack NEET by studying on YouTube? I'll reply. So, my dear, see, this is the opinion of mine which I try to share with you. See, you study anywhere. If you study on YouTube, you study on some app, you study on some offline center, you study on your school, okay? You study anywhere, 90% what you have to do, you have to study hard, okay? Okay, see, competitive exam is the simplest thing. Why it is the simplest thing to go forward for? You have a certain syllabus. There is nothing going to be outside the certain syllabus. Okay. Now, if you read the syllabus, I'll just tell you, if you read the syllabus completely, if you solve previous year questions completely, if you go for the mock test, if you solve multiple problems of each of the chapter, okay, so those who have cracked the NEET, you tell me, have they done anything else than that? Is there any other way to do this? Right? You are not a kid anymore, na? You have come to 11th, 12th class, so you are not a kid anymore. You tell me, those who have cracked the NEET, have they done anything other than this? What do you think? Okay. Now you have to do this thing. Whether you do it from YouTube, you do it from some app, you do it from anywhere. Right? Second thing, right now I'm taking the vector. Okay, I trust me on this. You check from wherever you want, from whichever teacher you want to go with, to offline, online, whichever city you go, everybody is more or less teaching the same thing. Because vector is not the creation of the teachers. Are you getting my point? Vector is a teachers are just the interpreters. We are just interpreting these things. Okay, and more or less the thing remain the same. Vector is not going to change whether you are studying from Dr. Umashankar Tripathi, who is me, you are studying from some other faculty. Doesn't matter, right? The matter is that whether you are studying or not, right? So what I believe, Shreya, I don't know. I have to also solve that. I normally have the questions with me. I don't have the solution. Are you getting my point? So I don't know. I'll also solve and we'll see whether the angle is 120 or what. We'll see to it. Okay. Danish. Okay. So what I can recommend you. Okay. See, you study with me. You study with anyone. Okay, beta. The thing you must do that each of the chapter, like if you are studying the vector with me, you must complete the vector with me only. You go to, like, for one chapter, if you are referring to multiple teachers, multiple concepts, that is going to be harmful. Okay, why? What happens? Because see, my way of teaching is one, well, another faculty might have a different way of teaching same concept given to you in two different aspects, right? It is going to create a mess in your mind, right? So basically, wherever you are studying, you just follow those things. If you are studying from me, you can follow me, right? Okay, but I recommend that you follow one teacher at least for one chapter, if not for the whole subject. I'm not telling you to follow me for the whole of the subject. If any one chapter you picked from any teacher, you must go for that chapter completely with that teacher only, at least. Are you getting my point? Especially in physics. Okay, because see, every teacher has a different way of explaining the things, na? So you get a few things right, and like, it may go wrong, right? Okay. She said, what is the answer? Can you give me the answer? Can you give me the answer, beta? No, nothing to be sorry about. You think it's B. Acha. We'll see. The sum of the let's try it. Let us try it together. Now see. So can you tell me, have you used analytical way or graphical way? Okay, let me tell you both the ways. Okay, let's first start with analytical. Now, I have seen one thing in students that normally when they see the questions of the vector, finding the resultant and all, normally this, analytical thing comes up in our mind first because we are good at memorizing the formula. And this formula comes out of us like out of nowhere. You start pasting the formula. Let me do like that first. Okay, then you can judge the thing. So the sum of the magnitude of two forces acting in the point is 18. So that means two forces are there. Let's name them A and B. So the sum of these two are 18. Very well. Now the resultant is 12. So R is 12. Now we know the formula of resultant. So R square is equal to A square plus B square plus 2AB cos theta. Right? Okay. Very well, sir. Now this R square is given. R is given, that is 12 square. Okay, so this is 144. This is 144. Okay, and this is A square plus B square plus 2AB cos theta. 2AB cos theta. Now, I give you one suggestion to all of the students. There is one piece of advice from me. Now, whenever you are solving a question and there are two variables to find it, you have one equation already. Now, what you must think of, in what direction you must start thinking? You must start thinking to make one more equation between these two variables. Are you getting my point? You must think of making one more equation between these two variables. So now this is one more equation. But sir, here there are three variables. Okay. See, simple funda. Number of variables shall be equal to the number of equations. Then only you will be able to solve that question. Otherwise, you won't be able to solve this question. Right? Now here in this, there are three variables. Okay. Okay, so there is something we need to eliminate. Now let's get back to the question and let's see what information they are giving us. So now this says if the resultant is 90 degree with the force of a smaller magnitude. I don't know. Let's suppose A is having the smaller magnitude. Now the resultant is going to be like this. Okay, 90 degree from it. I don't know where is B, but I'm very sure that B would be somewhere here, right? Sir, how come, sir, you are sure about it? Because see, the parallelogram, okay, the resultant is given by the diagonal of the parallelogram. Now. So when the resultant is given by the diagonal of the parallelogram, this B cannot be anywhere but on the left of this R. If you see, if you think a little geometrically, do you agree to this first of all before I move ahead? Please answer me. Please answer me. बोलिए. Wonderful. Now, अब हमारे को क्या दिक्कत ना? What is our problem? So our problem is, sir, we have to eliminate one variable in this second equation. Now for that, let's look into the information. So the information is that the resultant is at 90 degree from the smaller force. So when the resultant is at 90 degree from the smaller force, what we can say, sir, so we know one more formula. So tan alpha. So we are making this angle of resultant, we have considered this angle from A. So I shall write A B sine theta plus B cos theta, right? Now this alpha is given to be 90 degree. When this alpha is 90 degree, this alpha is 90 degree, this is going to be B sine theta plus A upon B cos theta. Now, sir, we know that tan 90 is undefined. It is basically 1 by 0. And this is B sine theta upon B sine theta upon A plus B cos theta. Now, from here, okay, I'll come back to it. So a plus, so see, you have to eliminate one variable. You have to make it in two variable, because see, it will then become the case of two equation, two variable. I think you must have done it in your 10th standard. Okay, how to solve two equation, two variables, right? Now from here, can I write a plus b cos theta is equal to 0? So simply b cos theta becomes minus a. Okay. Now do you follow me till this point? Yes or no? How we have done this? Yeah. Yeah. Please answer me. Do you follow me to this point? Are you able to follow me to this point? Wonderful. Wonderful. Now, if we put this back in this equation, this one, let's call it equation 1.1. Let's call it equation 1.1. Now, if I put it here, so it will become 144. It will become 144 a square plus b square plus 2ab cos theta. So b cos theta I can replace with minus a. So this will become b square minus a square is equal to 144. So I may write it like this also now. B square minus a square is equal to 144. Now definitely your question is going to get solved. How come, sir? Now you have one equation here, you have one equation here. Let us solve them. So we know b square minus a square is going to be b minus a, b plus a, b minus a, b plus a is equal to 144 is equal to 144. Now from here, can we say this, that b plus a already we have, that is 18, and this is 144. This is 144. So from here, can I write b minus a is equal to 144 by 18? Now when I do 144 by 18, how much we are getting, sir? How much we are getting? So 18, 8 times 144, right? 18, 8 times 144, right? Am I right or wrong? Yeah, right only, na? So, no. Just wait, just wait, just wait. There are a lot to it. Don't worry. Let me do it now. So, b minus a is equal to 8. Now we know b plus a is equal to 18. Now we can solve it. Now we can solve it. So, from here, b is going to be 13. Right? From here, b is going to be 13, and then a is going to be equal to 5. So, this is going to be your B option. Okay, 13 and 5. This is not 15. This is 13. Sorry, C option it will become now. C option it will become 13 and 5. Do you agree? Please answer me. Yeah? Or did I do something wrong here? Did I do something wrong? No. I did it right only. So it is going to become 13 and 5. So what is the option, beta? What is the option? The C option. Right? Is it clear to you? Please answer me. Okay. Okay. Is it clear? Okay. Now, when you have the value of A and B, you can put the value of A and B here. You can find the theta. You can find the theta. Understood, beta? Understood? Please answer me. Yeah? Yeah? Now, I tell you one thing. Sir, if I would have been at your place, I would never have done this question like this. It took very long, Naya. Don't you feel that it is taking too long from this way? Right? In the examination, are we going to give this much time to this question? Then what will happen to the other question? Now, let me give you this question again. Okay. Now, let's think. Let's think. Okay. Let's take a deep breath and think something. Okay. Now, if the graphical method would have come to our mind before the analytical, and if we would have approached to it, okay, then how the question would have been solved? Now, the sum of magnitude of two forces acting at a point is 18. Okay, very well. The magnitude of their resultant is 12. If the resultant is 90, the smaller force in magnitude, so can we say, okay, let's suppose A is the smaller force and now the resultant is 90 degree. The resultant is 90 degree and its magnitude is also given. So this is 90 degree. This is 90 degree. Now tell me one thing, my dear. From the triangle law of vectors, the resultant is the third side of the vector, third side of the triangle taken in opposite order. So wherever be the B vector, it has to be here now. What do you feel? Yes or no? Now please try to think of the triangle law of vector. Two vectors taken, two vectors given in magnitude and direction in the same order by two sides of the triangle, then the resultant will be given by the third side in opposite order. Okay. Now, if R is this, so this has to be the Vina. Do you feel this? Yes or no? Please answer me. What do you think? Yes or no? Yes or no? She say. What do you think? Wonderful. Now please think this way. Now this is 12, this is 90. This is 12, this is 90. This is 90. So what we can do, sir? What we can do? So from here, can we make some calculations, sir? What calculation we can make? So from here, this is A, this is B. So we can use the Pythagoras thing. So B square is going to be equal to A square plus 12 square. So this is going to be B square minus A square is equal to 144. B square minus A square is equal to 144. Now, do you think that in this method, this much we had to do to reach to this point? And here in this method, right away you can come up with this. Yeah, yes or no? Please answer me. Isn't it great? Isn't it? Just within 30 seconds you can do. And afterwards, B plus A is how much? It is given as 18. So now solving these two equations, you can get the answer very quickly, right? So not always analytical way is, going to give you the quickest solution. It definitely can give you the solution. So that is why, see, many people I have seen saying, "Arey, triangle law is having no use. It is not used." Arey, it is having extensively used. If you want to save your time, right? In the cases where 90 degrees there, you can use this. And after I tell you the sine rule, it is going to be very, very useful for you. Are you getting my point? Okay, right? Is it clear? Do you want to do one more question? Do you want to try one more? Yeah, yeah, it is now too easy. Yeah, now let's try one more. Start. Okay, okay. So let's try to apply the concept here in this question and the other way around. So this is a very interesting subject, na? And like in vectors, there are so many ways to deal in. Like when you go to the Cartesian way, there is one way to solve this question in the Cartesian way also. But like it will be too messy for you. But we can do that also if you say when we complete the Cartesian also. Okay, now let's try this. So now it's your will that you do it with analytical way, you do it graphical way, whichever way you may want to go for it, you can approach. Please go for it. Please go for it. Let's see whether we'll be able to do it or not. I'm waiting. Take your time. Wrong answer. Please take a deep breath. Then solve it. Don't worry. You know all the concept. You can do it. Okay. So you do the question. I'll take some water. Yeah. Now. So you have given 150. That is correct answer. Wonderful. So have you done it with analytically, graphically? And if you did it graphically, with which method you have done it? Can you tell me that? Have you done it graphically or analytically? That is mathematically. Using sine zero. Okay, you have done it graphically. Acha. Let's see. Let's see. So you graphically have applied, I guess, when you are saying 180 minus theta. I think you have applied the law of triangular forces, right? Uh, Shahida, my dear, welcome to the session. बेटा बेसिक से तो पढ़ाया है, लेकिन दिक्कत ये है कि आप जिस समय पे आए हैं तो वहाँ पे बेसिक खत्म हो चुके हैं. Yeah, Shahida. See, I'll tell you one thing. So see, this is the second session. So already we have spent, हमने already 2.5 घंटे का पिछला सेशन है वेक्टर का. आप पिछला सेशन से बेटा स्टार्ट करिए. ठीक है, तो पिछले सेशन से जब आप स्टार्ट करोगे ना तो एकदम बेसिक से चला है, मतलब उससे बेसिक कोई नहीं चला होगा जो मुझे लगता है. हाँ शेरा, हिंदी ही बोल रहा हूँ बेटा. ठीक है. ठीक है. सो आप एक बार पिछला सेशन देखिए, लेकिन हाँ, दिस इज एन इंग्लिश चैनल, लेट मी टेल यू. तो यहाँ पे मतलब जो नॉर्मल टीचिंग होगी वो इंग्लिश में होगी, बिकॉज दिस इज हाउ दिस चैनल इज. ये चैनल इंग्लिश चैनल है, तो यहाँ पे ना इंग्लिश में ही चलेगा वैसे तो. लेकिन अगर आप इंग्लिश में कंफर्टेबल हैं तो आप जाकर के पिछला सेशन पहले देखिए, वेक्टर का बेसिक ऑफ वेक्टर करके, है ना. एंड आफ्टरवर्ड्स आप इस सेशन में आएंगे तो आपको समझ में आएगा, क्योंकि अभी हम ना वेक्टर में बहुत आगे निकल गए हैं, समझ लो वहां से पीछे. शहीदा बेटा, आप देखिए, मैं रैंडम डाउट्स नहीं पिक करता हूँ. ठीक है, अगर जैसे अभी सेशन चल रहा है वेक्टर का, अगर आपका वेक्टर एडिशन सब्सट्रैक्शन से रिलेटेड कोई डाउट है तो यू आर मोस्ट वेलकम। या इट इज अ इंग्लिश बैच। शहीदा बेटा कुछ फिजिक्स देखो, मेरी बायोलॉजी बहुत वीक है, मैं डॉक्टर हूँ मैकेनिकल इंजीनियरिंग में, तो मेरी बायोलॉजी बहुत वीक है यार। देखो बेटा क्या होता है, जो सब्जेक्ट आप नहीं पढ़ते हो वो वीक हो जाता है। मैं बायोलॉजी नहीं जानता हूँ तो मेरी वीक है, मुझे उसकी बायोलॉजी का बी भी नहीं पता है। शाहिदा बेटा, अगर आप हिंदी में कंफर्टेबल हैं तो मैं आपको ना एक जेन्युइन एडवाइस ये दूंगा कि आप अन अकेडमी के हिंदी चैनल्स भी हैं जिसपे हिंदी में पढ़ाते हैं, तो वहां पे आप चले जाइए, वहां पे आपको हिंदी में पूरा कंटेंट मिल जाएगा, है ना? ठीक है। और अगर मान लीजिए आप मेरे से पढ़ने में इंटरेस्टेड हैं तो आप अन अकेडमी ऐप पे आ सकते हो, अन अकेडमी ऐप पे आइए, आप मेरे को ढूंढ लीजिए। अन अकेडमी ऐप पे मैं हिंदी में पढ़ाता हूँ, यूट्यूब पे इंग्लिश में पढ़ाता हूँ बेटा। लेकिन आप अगर यूट्यूब पे ही पढ़ना चाहते हो तो देयर आर अदर अन अकेडमी चैनल्स, आप बेटा वहाँ पे रेफर कर लीजिए, आपको हिंदी में पढ़ाई मिलेगी, क्योंकि ये डेडिकेटेडली इंग्लिश चैनल है। अगर मैं आपसे कहूँ कि नहीं आओ मेरे से पढ़ो और मैं पढ़ाऊँ इंग्लिश में, आपको समझ में ना आए तो बेटा आपका टाइम वेस्ट होगा, कोई फायदा नहीं है। और अभी से बेटा देखो, अभी आप 11th में हो, आप जब भी पेपर दो तो टाइम सबसे पहला काम, अगर मैं आपको ऐसा टीचर ऐसा बड़ा भाई सजेशन दूँ तो बेटा अपना टाइम मत वेस्ट करिए, अभी से पढ़ना शुरू कर दीजिए अगर आप नीट के एग्जाम को देना चाहते हैं भविष्य में। ठीक है। नहीं नहीं, पेड कोर्सेज नहीं, स्पेशल कोर्सेज है, स्पेशल कोर्सेज में भी है, मैं स्पेशल कोर्सेज में ही पढ़ा रहा हूँ अभी। ठीक है, वो एब्सोल्युटली फ्री है, उसमें कोई चार्जेस नहीं है। ठीक है, अन अकेडमी पे। या शिफाई, सी, we cannot make judgments, they are also teachers, they are working in some other, constrained environment. See, teacher, if a teacher is a teacher, he always want to teach. Are you getting my point? Shahida, it's absolutely free बेटा, अन अकेडमी ऐप पे स्पेशल क्लासेस है वो एब्सोल्युटली फ्री है। ठीक है, उसमें पेड कोर्सेज भी हैं, लेकिन ऐसा नहीं है कि स्पेशल क्लासेस, स्पेशल क्लास मीन्स फ्री क्लासेस। ठीक है, तो बहुत सारे टीचर फ्री क्लासेस में पढ़ाते हैं, मैं भी पढ़ाता हूँ, उसमें आपको फ्री क्लासेस भी मिल जाएगी, है ना? वरना आप यूट्यूब के अन अकेडमी चैनल पे और दूसरे चैनल से वहाँ पर भी एक बार रेफर कर सकते हैं। ठीक है, so let me continue with the question. Acha, I was talking to you, Shisai. Shisai, I guess you have solved this from the triangle law of vectors, right? Have you? No, no, Shisai, I don't. I teach on the app and on this channel on YouTube, as far as physics is concerned. Okay. So, Shisai, have you applied triangle law of forces, vectors? I think yes. Hannah, what do you say? शहीदा बेटा, इसका ना केवल एक रास्ता है। 100 लोग 100 तरीके की बातें आपको बता सकते हैं कि ऐसा कर लो, उल्टा खड़े होकर पढ़ लो, सुबह 12 बजे उठ के पढ़ लो, रात में 3 बजे उठ के पढ़ लो। मैं आपको एक सीधी सी बात बताता हूँ, जिस दिन आप किताब उठा के पढ़ना शुरू कर देंगे आराम से, उस दिन आपको समझ में आने लगेगा। जिस दिन आप पूरा लेक्चर ठीक से देखने लग जाओगे तो आपको समझ में आने लग जाएगा। इसका कोई शॉर्टकट नहीं है कि फिजिक्स को ऐसे समझ लो, वैसे समझ लो, ये कर लो, वो कर लो, सब बेकार की बात है। क्लियर है? So Shisa, you have applied the triangle law of vectors. Now I want you to do it with graphically from parallelogram law. I want you to try it graphically only. Don't go by analytical way. ठीक है? No, no. She's saying she's not comfortable in Hindi, na yaar. So here we are going to teach in English only. ठीक है शायद बेटा, तो यहाँ पे बेटा इंग्लिश में पढ़ाएंगे ना, तो आपको हो सकता है दिक्कत हो, तो इसलिए मतलब मैं नहीं रिकमेंड कर रहा हूँ, है ना? She said, let's get back to the point. So now you please try it with parallelogram law, but graphically. Don't apply the formula. Let's see if you can do it or not. See, I want that everything is clear in your mind. बिल्कुल conceptual clarity होनी चाहिए. Please go for it. चलो go chapter by chapter बेटा. हाँ शायद अब आप अनअकैडमी नीट करके सर्च कर लीजिए. हिंदी बहुत सारे हिंदी चैनल हैं. ठीक है, वहां पर आप एक बार जाकर के पढ़ लीजिए, कोई दिक्कत नहीं है. अब बहुत अच्छे टीचर्स हैं वहाँ. नहीं नहीं, वो तो ऑब्वियसली एनसीईआरटी तो इंग्लिश में ही है. टीचिंग आपको हिंदी में चाहिए तो प्योर जो हिंदी लैंग्वेज में आपको पढ़ाएंगे वो आपको यूट्यूब के दूसरे चैनल पे मिलेंगे अनअकैडमी के. हम इस चैनल पे हम लोग इंग्लिश में यूज करते हैं. दिस इज द इंग्लिश चैनल. ठीक है, या आपको अनअकैडमी की ऐप पे आना पड़ेगा. दो तरीके हो सकते हैं इसके. अनअकैडमी की ऐप पे बेटा जैसे मैंने आपको बताया, नॉट ऑल द कोर्सेज आर पेड कोर्सेज. वहाँ पे सारे कोर्सेज पेड कोर्सेज नहीं हैं, बहुत सारे फ्री कोर्सेज हैं और फ्री कोर्सेज में भी काफ़ी पढ़ाया जाता है. ठीक है, तो आप आ जाइए वहाँ पे. मतलब काफ़ी क्या पढ़ाया जाता है, पूरा ही पढ़ाया जाता है. ठीक है, आधा पढ़ाने का कुछ हिसाब तो होता नहीं है. ठीक है, तो आप वहाँ पे आ जाइए. वहाँ पे आपको पूरा हिंदी में मिल जाएगा. आपको मेरे लेक्चर्स वहाँ पे मिल जाएंगे. वो प्योरली इंग्लिश हिंदी में है. शुरुआत की एक दो लेक्चर शायद इंग्लिश में है, उसके बाद हिंदी इंग्लिश मिक्स और फिर हिंदी, क्योंकि पब्लिक डिमांड कहती है कि हिंदी में पढ़ाओ वहाँ पे. ठीक है, तो वहाँ पे मैं भी हिंदी में पढ़ाता हूँ. ठीक है, तो आप वो भी कर सकते हैं, ये भी कर सकते हैं, जो भी आपको इच्छा. हाँ, कॉन्सेप्ट पे आते हैं भाई. लेट्स कम बैक टू द कॉन्सेप्ट. Yashi said, have you tried it? Then wonderful. Now let me do it. Okay. So the resultant of two vectors A and B is perpendicular to the vector A and its magnitude is equal to half of magnitude of vector B. Okay. Find the angle between A and B. So एक vector है A. There is one vector that is A and A and B. The resultant is perpendicular to vector A. So this must be the resultant. Okay, and its magnitude is equal to half of magnitude of vector B. Now if this is A, this is R, so this has to be B. This has to be B, right? This has to be B, right? This has to be B. So this is A, this is R, this has to be B. So now this has to be B from that. So what we have applied? We have applied the triangle law of vectors. Now this is R, this is A. Now we need to find the angle between A and B. Now this is, let's suppose this is alpha. Let's assume it by some name alpha. No, let me assume it with some other name. No, let me assume it as X, because when I say alpha, you may confuse with that alpha that what we have got there, right? Okay, okay. Now please observe this. So we have X A R B. Now we need to find the angle between them. So if R is what is given, so the magnitude is equal to half of the magnitude of vector B. So this must be B by 2. Okay, and here in the triangle thing, we always see, the magnitude. All the sides give the magnitudes of the vector. Now from here can I get this X? So definitely, sir. So this is sine X. This is sine X. So sine X is going to be perpendicular upon hypotenuse. So it is going to be B by 2 upon B. So it is going to be sine X is going to be equal to 1 by 2. So X is going to be how much? So it is going to be 30. So what is the angle between these two vectors? What is the angle between these two vectors? So now here many students come up with a mistake. They say the angle between the vectors is 30. But no sir, it is not 30. Remember the angle, so that is why see every point is important. The angle between the two vectors is measured when they are joined. How? When they are joined tail to tail. So whenever you are seeing the angle between two vectors, you have to have them joined tail to tail. Yes or no? Yes or no? So when we are joining tail to tail, so I have to shift this A here now to see the angle. So this is B. So if I see the A here, if I do some parallel shifting of A, this is the theta now. This is the angle between these two vectors. Okay. So this is going to be 180 minus 30. So that is going to be 180 minus x. So x is 30. So this has to be 150. Clear? Yes or no? Wonderful, sir. Now, sir, let's see it through parallelogram law, but graphically only. Okay, so you can do this analytically also, but see, whenever 90 degrees mentioned, you always go graphically. It will be give you easier solution and you will be getting quick solution as well. So now please observe. Now let's try it. So we have a vector A. Now it is given the resultant is 90 degrees from A. Resultant is 90 degrees from A. Now I understand that B is somewhere here because see, sir, why you are saying that should be somewhere here? So B should be somewhere here because this is the resultant, and resultant given by the resultant is given by the diagonal of the parallelogram. So this diagonal is there, so this has to be the parallelogram. So B should be somewhere there. B should be somewhere like this. Yes or no? Definitely, sir, B should be somewhere like this. So if B should be somewhere like this, if B is somewhere like this, so you can see what? So let's suppose this angle is x now. This angle is x now. Okay. Now what is going to be this angle? What is going to be this angle? So see, R is what? It is B by 2. B by 2. And this is B. This is B by 2. Okay. And this is going to be what? A. Obviously it is A. Now you see one more triangle. So let's suppose this is OMN. Now in triangle OMN, we have cos x is equal to base, that is B by 2, upon hypotenuse. So hypotenuse is B. So from here, x is going to be 60 degree. Yes or no? Cos inverse half. X is going to be 60 degree. So x is going to be 60 degrees. So see, as a student, whenever we see x, because bachpan se from very small standards, we have find x, find x, find x. So whenever we consider something x and we get to find the x, we forget what is asked in the question and we mark this x. Okay, that is why you see the option. See, these people are very smart people who make these papers now. These are very smart people, and also they want you to give the wrong answer, right? So each of these options are not randomly placed options. Are you getting my point? They give enough time to frame these options. They are not randomly. Here the answer is 150, so let's do 135, 160, something like that. Every option with each, if you make any silly mistake, you will land up to one option. And see, this is the tendency of ours. Whenever we do some solution, we do something in that immense pressure atmosphere is there, sir. We have studied so much. Okay. And afterwards, what happens? So when we see like we have found something and that is matching with any of the option, what we think, okay, we got this option is there, let's take it. Don't do that. Are you getting my point? Don't do that. You may land up to the wrong answer. Never, never, never think that you are having some value that is given in the option. So your answer is right. See, this time there is one more thing. I'll come up with a video on this. Okay, mostly by today I will make the video on this. Okay, there is one new notification. So the old system, if I tell you that is of no use. Are you getting my point? But ultimately, whosoever agency is making the paper, okay, they will hire some experts. Who are the experts? The experts who are working in premier institute, okay, for physics, like they may ask some Indian Institute of Technology professor or associate professor to come up to frame questions. Okay. Also, not one faculty framing all the question. They give you some questions to some faculty, some question to some faculty. There is a moderator also, like he pick up questions from many of the senior professors. Then he sort it out. Okay, this has to be framed. This has to be framed. So it is a good enough process, and very intelligent, very smart people are making these papers. Okay. Okay. And normally their age is between 55 to 60 because they are senior professors. No, they don't do like that. They don't do like that. Don't think this way. See, they are IIT professors. I tell you, I live in IIT. I am here in IIT from last 10 years. Okay. I did MTech here. I did PhD here. Okay. And afterwards also I am living in Roorkee only because I have some research activities to do at IIT lab. Okay. Now please understand this, my dear. If you see any professors of IIT, he has a different aura altogether. Okay, they are not like that. So when someone is working at such premium institute, they never even think of this thing. What you are saying, right? It is out of question. Getting my point? Okay, okay. They never do this thing. Getting my point? Otherwise, the CBSE chairman, son or daughter, might be getting All India rank one in the 10th and 12th board, but till now, is it happened ever? Hmm? They don't do like that, right? Okay, very good. Okay, so this let's come back to this question. Okay, so now please observe. So we have x is equal to 60 here, and this is 90. Now here both the vectors are already connected tail to tail. So what is going to be the angle between them? So again we are going to get 150 degree. Again we are going to get 150 degrees. So the answer is again obviously from triangle law, from parallelogram law, whichever law you apply, you are going to get the same answer only. Right? Is it okay? Good to go? Now please tell me one thing. Are you now confident in applying the vector law? Yeah. Can we say that you are confident now? Shall we come to go for the next concept? Right? Hmm? Can we move to the next concept now? If you want some more time, if you want some more question, you can ask me. But see, the questions I have given you in each of the questions, see, I have no purpose that I solve, simple questions. Okay. See, we start from simple questions only. We increase if you follow my tendencies, you will see that each of the question is going to give you some concept, right? Wonderful. Let's move forward. Now, I want your 100% attention to this class, to everyone who is watching. Okay. Now, please observe. See, now let's break a myth in vectors. So there is something called as vector subtraction. I don't believe there is something like vector subtraction. Now let's talk about it. Now it seems like vector A is subtracted, sorry, vector B is subtracted from vector A. It seems like this. But is it two vectors are getting subtracted? Now please understand this. Let's suppose, let's suppose we are having two vectors. One is A and one is B. Like this. One is B like this. Okay. And we are asked to find, sir, what is the difference of vector A and vector B? What is the difference of vector A and vector B? Now, sir, how we get the difference of it? Sir, there is no law of subtraction. There is only law of addition. Now, can we write it like this? Please observe. Very, very interesting. Now, can I write it like this also? A plus minus of vector B. Can we write like this also? Can we write like this also? Yes, sir, definitely you can write like this also. Now, what is minus of vector B? So, minus of vector B, so if you remember, in when we were dealing with the basics, I have given you one concept of negative of a vector. So, do you feel that this minus B vector is nothing but negative of this vector B? Negative of this vector B. Do you agree or not? So, basically, what you are asked to, so this is vector B, and and this is negative of vector B. Just have it reverse in direction and same having the same magnitude. If you remember, the negative of vector is when vector reversed in its direction. Okay, keeping the magnitude same. So if we keep the magnitude of B same and we reverse it, in the direction it would look like this. So basically, when you are writing this, basically this is the vector b. Okay, this is the vector b, and this is the negative of vector b. So rather than finding the resultant of vector A and B, you are finding the resultant of vector A and negative of vector B. That means that again you are finding the resultant of two vectors which are added, okay, which are added. So are you doing anything different from what we have learned till now? What do you think? Can you have it in your mind? Do you understand what I'm trying to tell you? Okay, there is nothing like subtraction. Two vectors are never subtracted, they are always added. You get always the resultant, right? So when you write A minus vector B, it doesn't mean anything, but just A plus negative of vector B. A plus negative of vector B. Are you getting my point? Please answer me. Right? Now we want to find A vector B. Now please understand this. Now be very careful. Be very careful. So the angle between two vectors is theta, because the question will say that the angle between vector A and B is theta. So here the B is what? This is B. This is B now. This is B. Yeah, vector A is added with negative of vector of B, right? Which itself is a vector. Which itself is a vector. Yes or no? We already have learned this, that if two vectors having the same magnitude but they are having different directions, they are two different vectors. So minus b is nothing but you can say that this is vector c, you name it something different. Okay, so simply vector a is added with vector c. Now please understand this. Okay, let's suppose that the angle between vector A and vector B is theta. Now again mind you, this theta is the angle between A and B, not A and negative of B. Now if the angle between A and B, if the angle between A and B is theta, what is going to be the angle between vector A and negative of vector B? So this is going to be 180 minus theta, isn't it? Isn't it? And now you want to find the resultant of these vectors. Now you want to find the resultant of these two. So when you will be finding the resultant of these two, how you find resultant of two vectors? So we have the law of parallelogram of forces. So a square plus b square, let's write r square, a square plus b square plus 2ab. And so we put the angle between the two vectors. Okay. Now here, what is the angle between the two vectors, sir? A and B. The angle between two vectors is, sir, r square, a square plus b square. So the angle is 180 minus theta. So cos 180 minus theta is the minus cos theta. Right? I hope you know that. If you don't know it, you know it now. So now what people say? Sir, this is the formula of vector A minus vector B. So if vector A minus vector B has a resultant, let's suppose R dash, just for the sake of having it different from that what we have got previously, let's call it R dash. So this R dash, the magnitude of this R dash will be given by root over A square plus B square minus 2ab cos theta. But are we applying any new principle or are we just adding two vectors? Please tell me. Please tell me. I hope it is fine to you. Right? I hope this is fine to you. Right or wrong? I hope this is fine to you. Yeah? What do you say? Now similarly, Vida. Now please observe. So, sir, we wanted one more thing, sir. We wanted alpha also. We wanted alpha also. So now where will be the direction of the resultant? This R dash, do you feel that this R dash will be somewhere, this R dash is got to be somewhere here, okay, somewhere here in the middle of this A and B, because it is given by the diagonal of the parallelogram, okay. So this is going to be the R. And let's suppose this angle is alpha. So can I write tan alpha? I'll just write it here so that we can write the formula there. Tan alpha. So we know, sir, from where it makes the angle, we write it separately. So it is A. Now B sine theta. So B sine 180 minus theta upon A plus B cos 180 minus theta. Now sine 180 minus theta is sine theta only. 180 sine 180 minus theta is sine theta only, and cos 180 minus theta is minus of cos theta. So it will become A minus B of cos theta. Yeah, don't worry. We'll solve questions. Will not let you make mistakes. Don't worry. Right? Right? Now these are the formulas. So what is this alpha? This alpha is the alpha. Alpha is angle between R dash and A, right? R dash and A. So these are the two formulas that you can use in this case, or you can go by graphic, right? Your choice. Understood, my dear? And the most important thing where I have seen students making mistake is in this theta. So is the theta angle between A and B or A and negative of B? So remember the theta we are using here now is the angle between A and B, not the angle between A and negative of B. Don't have this confusion in your mind. Theta is the angle between A vector and the B vector. 180 minus theta is the angle between A vector and negative of B vector. They both are not the same. So here the formula that we have developed in this, the theta is the angle between the original A and B vector. So never have this confusion. Okay. Is it clear to you? Is it clear to you? Okay. Okay. Please answer me. Okay. Now please understand it. Let's do one thing. Let's do it one question. Acha. Let's say we are having two vectors A and B. Okay. A and B. Okay. Somewhere A is here, B is here. Let's try. Now, what we can do, let's just observe. I'll do. You just observe. Okay. I will have some questions. So this is vector A and this is vector B. Now, if I ask you, sir, vector A plus B. Let's suppose vector A plus vector B, and let's suppose the resultant is R vector. So, sir, we know it. How we know it, sir? We are going to do some parallel shifting. So this is A and this is B. This is A and this is going to be B. We join them tail to tail. Then we completed the parallelogram. Once we have completed the parallelogram, we can say this is the R. This is the resultant R. Right? This is the resultant R. Understood, beta? Understood? Yeah? Please answer me. Please answer me. Yes, sir. Yes, sir. Now, similarly, sir. Now, similarly, if you see A minus B, let's suppose vector A minus vector B, the resultant to it is R dash vector. Now, negative of vector B means that we are referring to this one. This is the negative of vector B. This is the negative of vector B. So this is when this is the negative of vector B. This is the negative of vector B. So minus B makes no sense. But minus when I put vector sign, then it makes the sense. So this is going to be the resultant of it. This is going to be the resultant of it. Do you agree or not? Please answer me. Do you agree or not? Please tell me. Yes or no? Yes or no? Okay. Okay. Now please understand this. Please understand this. So basically from here, what I'm trying to establish to you is that vector R and vector R dash are not equal vectors. Are they equal vectors, sir? Are they equal vectors, sir? So they are absolutely not equal vectors. Understood, my dear? They are absolutely not equal vectors. Do you agree to it on me with me? Yes or no? Please answer me. Right? So basically the resultant of two vectors added and subtracted are different. Now let's say if, let's frame a question here. Now if we have vector A plus vector B, its magnitude is equal to vector A minus vector B. Okay, its magnitude is equal to vector A minus vector B. So can we say, now you have to tell me the angle between vectors A and B. You have to tell me the angle between. Acha, you were going to ask that. Okay, the angle between vectors A and B. Now you have to solve it. 0 degree, 60 degree, 90 degree, and 180 degree. Please go for it. Please go for it. I'm very sure we can do it. Please go for it. So in this case, their magnitude is equal or not? No, so they are not equal. See, by looking also, you cannot say they are equal now, right? Okay, because I can see that it is at some angle. Wonderful, wonderful. Okay, now in this case, my dear, in this case, see what happens. So what they are asking you. So see, again, you can think graphically, you can think analytically, whichever way you want. Let's try it analytically. We have done graphically also now. Now A plus B. So this is basically the resultant of two vectors being added. So we know the formula, sir. A square plus B square plus 2AB cos theta. Okay. And now vector A minus vector B. So this is basically the magnitude of the resultant of these two vectors A minus B. Right? Okay. So now the formula is the A square plus B square minus 2AB cos theta, A square plus B square minus 2AB cos theta, right? Both are equal, so can we write like this? And the theta is same in both the formulas. The theta is same. It is the angle between A and B. Shita, you are asking, sir, my question was a bit different. Is the resultant vector same, not the magnitude? What are you trying to say? I think you got the answer. Resultant vectors of A plus B, A minus B can never be same, because even they have equal magnitude, they can never have the same direction. And two vectors are said to be same when they have same magnitude and same direction both. So if you are asking me that resultant vectors can be same in any condition, there is no such condition. Talking about the magnitude only, there is one condition that we are talking about. Okay. Okay. So see these points. So in the basics, when I say okay, vectors, I tell you, I'm not talking about you, but the general student tendency, or is that why you are, we know all these things. That vector is given by magnitude, direction. But the question is, you know it and do you feel it? See, in physics, things have to be felt. And where this concept is going to be used, sometimes very basic things have the most high impact in solving the questions. Okay, so from here, can we write A square plus B square, that will be cancelled out. So here, cos theta is obviously becoming 0 now. So 2AB plus 2AB will be 4AB. 4AB cos theta is equal to 0. So from here we can write theta is equal to 90 degree. So this is the only condition when these two vectors are equal. Now you can see this, graphically also. There is one vector A, one vector B. So now see, I know that all of us know this much geometry, right? When they both are added vectorly, so this is going to be the resultant. Now so this is R, that is vector A minus B. Okay, this is vector A minus B. Now if we take the this is R, that is the resultant of A plus B, vector A plus vector B. No, is it anti-parallel? Is it anti-parallel? Anti-parallel is this beta. This is not anti-parallel. This is anti-parallel. Anti-parallel is this beta. This is what we call as anti-parallel. Please say, are you getting my point? You cannot call it anti-parallel beta. Anti-parallel is not that. Right? I hope you got my point. Yes or no? Resultant of vector A. You got my point, na? You got my point. Chill. Let's come back here. So vector A plus vector B, they have this resultant R. Now, if I write vector A minus vector B, so this is negative of vector B. So this is negative of vector B. Now, if you join this, it will be the same parallelogram, just a mirror image sort of thing. A plus B and resultant of A minus B are anti-parallel. No, 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 no. Are you referring? She said, let's talk about it. Are you so? This R is A plus B. Are you referring to this? And the resultant of A minus B is this. So this is not anti-parallel if you are referring to this. So what is A plus B? You are writing A plus B and resultant of A minus B R. So this is the resultant of A plus B. That is, this is vector A plus B, and this is vector A minus B. This is the resultant of vector A plus B combined. This is the resultant of vector A minus B combined. These are not anti-parallel. I think I'm not getting your question right. Okay, you got it. Anti-parallel means, see, this is anti-parallel. This is not anti-parallel, right? This is just two vectors having different direction. These are unequal vectors. So now let's come back to here. So A plus B when added, that is they are having the resultant R. So this is resultant R. Now A and B when subtracted, that is A plus minus of vector B. So this is going to be the minus of vector B. So when this is going to be the minus of vector B, this is going to be the resultant to it. So this is R dash. So now geometrically also you can see that when the angle between A and B is 90, the magnitude of their resultant, that means A plus B, okay, this is the magnitude of the resultant, that is R, and vector A minus of vector B, this is R dash. So in this case both are equal clearly. Yeah, please answer me. What do you think? Hmm? Is it fine, my dear? Okay. So I think we can keep it to this point. I think you got the basics of addition, subtraction. So in the next session, what we'll do, I'll come up with more questions of subtraction. Okay, because this is of high use case. Because if we want to get the acceleration, we want to have the change in velocity. In uniform circular motion, also there is change in velocity. So this has a high use case in physics. Two vectors, the difference of two vectors, right? Okay, like for example, I previously also have told you this. So let's suppose that something has moved in east by 5 meter per second, or let's say 7 meter per second, okay, in this east direction. Now, with the same speed, it turned to north. Will there be any acceleration? First tell me that. Someone moved at a speed of 7 meters per second in the east direction, then took a left turn and turned towards the north with the same speed. Okay, will it have some acceleration? But magnitude is not changing. So, sir, even though magnitude is not changing, it will have some acceleration. Why, sir? Why, sir? Because see, acceleration is what? Change in velocity upon changing time. Okay. So acceleration is going to be change in velocity. That is what a change. Final minus initial. So that is v2 vector minus v1 vector upon delta t. Upon delta t. Okay. Okay. Now, even though the magnitude of velocity is not changing, but the direction is changing, that means the vector is changing. And when the velocity changes, we all know that there will be acceleration in the body, right? Okay. Now, in this case, we can apply yes, vector sum. So, see how you are going to do it. So, can you? Acha, chalo, let's first of all let you digest whatever we have learned today, because addition, subtraction, you do some question yourself from previous year question from somewhere, from some mock test, practice questions, mock questions, whatever. Okay, and afterwards we'll apply all this concept in the next session. Sound good? Okay. So much concept have happened today, na? Right? And I think class also, yeah, change won't be zero. How it will be zero? This is the difference of two vectors quantities being subtracted. So you are not merely writing 7 minus 7, right? Here v2 minus v1 is certainly not 0. 7, so in vectors, that is the first thing I told you. In a scalar, 7 minus 7 is also always 0. In vector, 7 minus 7 can be anything between 0 to 14. 7 and minus 7. Again, listen to me. In vectors, 7 and minus 7 can be 7 vector minus 7 vector can be anything between 0 to 14. Are you getting my point? Okay. In this case, it is not going to be 0. Right? Remember the first thing I told you in the vectors? Yeah. Remember that, beta? Okay. So, guys, I'll say that will be all in this session. We'll keep it to this point. And in the next session, I'll come up with vector again, because this is something in middle. So in the next session, we'll do some more questions on subtraction, vector subtraction, so that we can understand more use case of it. And then we'll move to the resolution thing. Okay, actually resolution thing we can wait also, because in kinematics. Oh, very good, Sri Sai. Thank you for such words. Okay, so basically you have to be consistent. Okay, we are trying to do our best, and same you must also do. Okay, anyways, so let's meet in the next session, and we'll continue from this point onwards. In the next session, I'll come up with some question. We'll see if we go to the resolution with the flow of the lecture, or otherwise we can come up with the graphs in kinematics. That is something is pending from the motion in the first. So basically in like uniform circular motion, projectile motion, these concepts are very much useful. Resolution also get used in the projectile thing. We'll do the resolution also in one go. No, no, no. Okay. No, no, Fisher, there's nothing to be angry about in that. Okay. So let's call it a day. Thank you very much. Have a good day. Please subscribe the channel. Please like the video. Please share to your friends so that more students can come and get benefited. No, 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 she said there's nothing like that. Okay. So let's meet in the next section. Have a good day. We'll see you in the next session. Thank you.